Okay, so last class we talked about arithmetic sequences. So arithmetic sequences, again, are things where you add something every single time. So if I started with like 1 and I added 3 each time, I'd go 1, 4, 7, 10, etc. So that would be an arithmetic sequence of adding 3. Today we're going to talk about geometric sequences, and geometric sequences is obtained by multiplying the preceding term by a constant non-zero. So a geometric sequence would be something like 1, 3, 9, 27, and I get those numbers because I multiply by 3 every single time. So the formula to find one specific term of your geometric sequence is going to be a sub n is equal to a sub 1, which is your first term, and your R is your common ratio. For the example that I just did here up in blue, my ratio would be 3. That's what I'm multiplying by each and every time. So let's go ahead and look at an example here. I'm going to find a sub 5 and a sub n for the geometric sequence 4, negative 12, 36, negative 148. So what is happening every single time? That I go from 4 to negative 12, to negative 12, from negative 12 to 36. I am multiplying every single time by a negative 3. Okay, now that's my rate. So my ratio, my common ratio is 3. And if you're not sure what your common ratio is, you can find it by following this formula up here. Except there is a typo. This little exclamation point should actually be a 1. So it is a n plus 1 over a sub n. So if I was using my formula for this geometric sequence to figure out my ratio, I would take any term like negative 12, for example, and divide by the previous term of 4, which gives me that negative 3. When these numbers are nice and easy to see what's being multiplied, it's okay for us to just, figure out the ratio that way. But there might be some that have decimals on your homework that you might need to use this formula for. So now that I know my rate, I know my first term. My first term here is 4. So I can plug that information in for a sub n and write my equation. So my equation for any term in a geometric sequence of this given sequence here is a sub n is equal to 4 times the ratio, which is 3, raised to the n minus 1 power. Okay, this does not simplify to give me 12 to the n minus 1 power. Okay, only 3 is being raised to the power of n minus 1. So that is my a sub n formula. And if I was finding a sub 5, I would just plug in 5 where I see n. So I've got 4 times 3 to the 5 minus 1 power. So if I simplify that, plug that in my calculator, a sub 5 is going to equal 324. All right. Next one here, we're trying to find a sub 1 and r for the geometric sequence with a sub 3 is 20 and a sub 6 is 160. So using that formula up above, we need to figure out what my common ratio is going to be. Now, I'm not given two terms that are right next to each other, but let's think about this. If I have a sub 3 is 20, a sub 4, a sub 5 we don't know, and a sub 6 we do know, how many times am I going to have to multiply that common ratio together in order to get from 20 to 160? Hopefully you answered to yourself kind of 3 times, right? I'm timesing the ratio 1 time, 2 times, and 3 times in order to get to 160. So since we're talking geometric sequence series, we're talking about multiplication and then division. So if I want to figure out what my ratio is, I can just think, okay, well, what is 160 divided by 20? That is going to equal the amount of ratios where I would take r to the 6 minus 3, or the highest term in the sequence here, because I'm multiplying it 3 times. So if I simplify this, I get 8 is equal to r cubed, and if I took the cube root of both sides, I get that r is equal to 2. Now if I multiply by 2, I get 40, 80, and then 160. So I do end up finding my common ratio without having to use a system of equations. So your ratio here is 2, and now I can go ahead and use that to find out what A1 is. So I can pick either A sub 3 or A sub 6, it doesn't matter. But if I plug it back into that formula that we were given up above, I can find A sub 1. So I'm going to choose A sub 3 being 20. So I've got 20 is equal to A sub 1 times R, which we know R is 2, to the n minus 1 power. So that's 3 minus 1. So just a little bit of algebra. 20 equals A sub 1, 2 squared. So A sub 1 is 20 divided by 4, or A sub 1 is equal to 5. So those were 2 examples showing how to find a specific term in your geometric sequence. Now, this next example is talking about finding the sum of a geometric sequence. Okay, so your formula for a sum of a geometric sequence is given below. And again, these are also on your formula sheet that you'll be able to use on your quiz and test. So we're given this notation here as a sigma from 1 to 6 of 2 times 3 to the I. Now again, you can still just plug this in your calculator. You'll get the answer. You can also still just evaluate these individually. So like if I plugged in 1, that would be 2 times 3 to the first power. If I plugged in 2, that would be 2 times 3 squared. And if I go all the way up to 6 and then add those together, I would find my summation. But I can also use this formula that has been derived for us. So if I was trying to find the sum of the first n terms in the sequence, for this example, we're finding the first 6 terms. So it'd be S sub 6 is equal to, well, I do need to know what my A sub 1 term is, so I do actually need to at least plug that in. That would give me 6. So I've got 6 times 1 minus your rate is the base before your exponent. So I'm multiplying by 3 to the power of I, meaning each time I'm going to multiply by 1 more I to get my next term. So your rate in this case, your common ratio, is 3. So I've got 1 minus 3, and then our n in this case is 6. So to the 6th power, all divided by 1 minus your common ratio of 3. And if we plug this into our calculator, we would simplify it to get 2,184 is the summation of the first 6 geometric terms in the sequence. Okay, so on the previous page, we talked about the sum of a finite geometric sequence. This is the sum of an infinite geometric sequence, okay, where we still have our first term of A sub 1, and we still have our common ratio of R. However, it is important that our ratio is in between 1 and negative 1. But before we dive into that too much, I want you, if you're listening, to go ahead and send me an email about your favorite thing about Thanksgiving, whether it's the food, what kind of food, if it's an activity you and your family do, what is that? Send that to me and I'll give you some extra credit on a quiz as a thank you for listening to me. All right, anyways, let's get into it. So I've got a formula here for our infinite sum of a geometric sequence is A sub 1 over 1 minus R. So I'm given this series here from 1 to infinity of negative 3/4 times negative 1/2 I to the negative 1. So looking at this information, I can find my first term by saying a sub 1 is equal to, and I'm going to plug in 1 where I see I. So negative 3/4 times negative 1/2, 1 minus 1. 1 minus 1 is 0, and anything to the 0 power is 1. So that goes away, and I'm left with just negative 3/4. So I have a sub 1. My common ratio can be found by looking at the base of my exponent with my variable. So my common ratio in this case is negative 1/2. And that's all I need for my formula. So the summation of all terms, okay, is going to equal negative 3/4, or A1, divided by 1 minus negative 1/2. If I simplify this, I get negative 3/4 divided by, if I add these together, that would be the same as 3/2. So dividing these fractions is the same as multiplying by the reciprocal. So this would be like multiplying by 2/3, which actually just ends up giving me negative 1/2. So if you add all the terms from 1 to infinity of this series right there, you would end up with negative 1/2. There's a really good kind of visual proof of this that I will also include on Schoology if you're kind of wondering why it is the way that it is. Like, why, if I add all the numbers from 1 to infinity of this sequence, am I going to get just negative 1/2? That seems pretty crazy to add all of those numbers together and only get negative 1/2, but it does in fact happen. So there is a video posted for you guys to watch if you would like as well. Letter B, I'm going to do the same thing. I need to find my a sub 1, my first term, and I need to find my rate. So first term, I'm going to plug in 1 where I see I. So that means my first term is just 3/5. My common ratio is going to be the base of my exponent here. So my common ratio is 3/5 as well. So I plug this stuff into my formula. My summation of 1 to infinity is going to equal 3/5, all divided by 1 minus 3/5. That gives me 3/5 divided by 2/5, or multiplied by the reciprocal, which gives me 3/2. So the summation from everything 1 to infinity of 3/5 to the I is equal to 3/2. All right, and our last example here is a little bit of a word problem, but we really just got to kind of gather out some things in order to solve it. So we're given another formula here, and it's the future value of an annuity, which is a sequence of equal payments made at equal intervals, such as car payments or house payments, can be found by using our following formula, where S is the future value, R is the payment at the end of each period, I is your interest rate in decimal form, important to note, and then N is the number of periods. So we're given some information here in this example. It says to save money for a trip, Callie is depositing $1,000 at the end of each year for 4 years in an account that's paying 3% interest annually. So find the future value of this annuity. So I know that R is going to be $1,000. My N is the number of periods, the number of years. So N is going to be 4 years. And then my interest rate as a decimal would be 3%, which is 0.03. And now I can just plug this information in. So the future value of this annuity would be S is equal to 1,000 times 1 plus 0.03 to the 4th power minus 1 all divided by 0.03. Now, on a quiz or a test, I would like to at least see this formula, because if you plug it in the calculator and you get the wrong answer, I can't give you the partial credit. But if you at least show this work and then plug it in the calculator wrong, I can give you some partial credit. But I would go ahead and suggest using your alpha y equals on your calculator to plug this in and just plug it all in at the same time. But we should end up with a total of 4183.63. So $8,183.63 would be your answer of the future annuity for this problem. Okay, your homework is on Schoology. Answer key has been posted. Please let me know if you have any questions, but the rest of class is work time for you guys. If you made it this far, I appreciate you for listening, and I hope you have a great rest of your day.